Okay, now this is actually labeled as a group B. This is naming using the suffixes for your organic compounds. I'm going to draw a chain here, 2, 3, 4, 5. 5 is enough for me. And I'm going to make sure that we have a double bond here. Once again, we want to go with the same idea of numbering it so that the least number is applied to it. And if we went from left to right, we would count 1, 2, 3, 4, 5, 6. And that would place the double bond on the fourth carbon, which is not what we want, because if we number from the other direction, it would go 1, 2. It would put it on the second carbon. 3, 4, 5, 6. I don't know why I'm sticking with hexane, but I am. So with this, instead of being hexane, this would actually be called hexene because of that double bond on the second carbon. And so this would be 2-hexene. Now, if you have substituents in here, you use the same idea again. Only thing that's different because we have a double bond is that we have a different suffix. So if we had 3, 4, 5, 6, that's good. Do that again. We're going to put our double bond in here, and then we're going to label this as, let's say we've got a substituent on here. We've got a bromine, and then over here let's have a we could actually have a methyl group coming off of that. Same idea. The chain is got a double bond in it. We want to number it so that we have the least number on the substituents. So we go 1, 2, 3, 4, 5, 6. The double bond would actually take precedence on this. So if we numbered the other way, 1, 2, 3, we would see that this would be the third carbon. The double bond would take precedence in the numbering, but it's 3 from either direction. So we'll go with it numbered the way I did, left to right. So we've got bromine and we've got a methyl. So bromine, methyl. Alphabetically, bromo comes first. So here we would name this as 1. I'm dumb today. 2 bromo. And then we'd have 3 methyl. And this would be 3 hexene. And the ENE denotes that there's a... See, the ENE tells us that there's a double bond, and the 2 tells us where it's located. Same thing over here on the more complicated one. Now let's go a little further, because sometimes you're going to run across a molecule that's going to have a double bond, and then later on in the same molecule, it's going to have another double bond, like this one. In this case, we would number it 1, 2, 3, 4, 5. There's 5 carbons. This is symmetrical, so we can number it from either direction. But we need to know the numbers of the carbons. And I start number. What kind of 1, 2, 3, 4, 5. And so we'll see that we have a double bond on the first carbon. We also have a double bond on the fourth carbon. So how would we name this? Well, we would name this as 1, 4, and this is 1, 2, 3, 4, 5. Penta. That's supposed to be a D. Diene. Pentadiene. And that tells us where they both are. Pentadiene. 1,4 is the pentadiene. Okay, what if we have a triple bond in it? Well, triple bond, instead of being an ENE, it's YNE, just as the instructions give you there. So let's say that we had the same molecule, same idea to it, but on this end we had a triple bond, and this end we had a double bond. Now, which one is going to get the precedence here? Well, this is no longer symmetrical, so we'd have to number it as either 1, let's put that in red, 1, 2, 3, 4, 5, or the opposite direction, 1, 2, 3, 4, 5. Well, we're going to number this one from right to left, because right to left, our triple bond has a lower number, and the triple bond takes precedence over the double bond. So with this, we'll wind up with both a Y and an E in our suffix name. And so we would number this as 4. No, I did that wrong. It's penta 4-ene. I forgot my dash. and then 1 ein. And I know that is incredibly awkward to say. Pint 4 ein, 1 ein. And that's really strange, but that's how it works. Oh, well, we'll talk about cyclos in the next one.